Hello, 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 everybody. Thank you for joining me. I'm going to be starting a new contest series. We're going to be going through the Manitoba Mathematical Competition. So this is the first of the papers that I've been able to get from their site. If you'd like a copy of this paper, you can click the first link, as with most of my videos. Get a copy of it to try for yourself. It'll be the 2008 MMC, Manitoba Mathematical Competition. And the second link will take you to their current website as of recording now, where you can get other contests of theirs. Now, on their site, they do have the 2003 and 2004, but then they have a bit of a gap, and they do have the 2007 in French, but I'm not so strong with my French, so we'll be starting with the 2008. My understanding is this contest goes all the way back to the 50s, but their site doesn't have them. And that's okay. The Waterloo site doesn't have all their contests back to the 60s. So they only go back to about 1997. So we're going to be starting with the 2008. A little bit more about this competition. It's, I believe, written on the same day as the Pascal, Cayley, and Fermat, the multiple choice grade 9, 10, and 11 competitions. And so it's a nice little competition. It's for grade 12 students. That's the intended target. So it gives them something to do on the day when the PCF is being written. And it isn't multiple choice. It requires justification, just like most of the Euclid questions. It's a nice little warm-up for the Euclid. I find that the questions here are a little less directed, a little more directed than the Euclid. The Euclid is the one I find a little less directed. The Euclid usually says, here's a concept, and then let's do some things with this concept, whereas this contest is more, solve for X, do this, prove exactly this statement, that sort of thing. So this one is definitely a little more directed, and I also find it's just a little easier, but that's okay. We get less time than the Euclid to write it, and I'm probably going to stop comparing it to the Euclid at some point. But we only have 2 hours to write the MMC, whereas 2.5 for the Euclid. And here everything needs to be justified. So let's take a look here. I'll be going through one question per video, like I always do. And 10 questions, not unlike our good friend the Euclid. It's only written for Manitoba students, is my understanding, although I think they might be trying to branch out to related provinces like Saskatchewan and probably maybe Northern Ontario, maybe Alberta. Maybe it'll become the Western Canada math contest at some point. But, yeah, so we're going through question 1, A and B parts in this video. I wanted to get the target audience and the length of time for this contest out of the way, because it doesn't actually say that. Another thing it doesn't say, no calculators. No calculators on this contest, so you're going to have to be exact, and hopefully we won't ever be called upon to do something crazy like 7,384,222 squared. I don't see that happening, but just know that our calculators get put away. Okay? So, as I say, if you'd like to download a copy, try it, give yourself 2 hours, see what you can do, see if you can justify things, and then you can come back and take a look at any of these videos. So, 1a, solve the equation x plus 6 over x plus 1 equals 4. So this is what I mean when I say this is more directed. I also find the Euclid language to be a little softer, something like find the values of x that satisfy, or that sort of thing. But either way, it's the same sort of thing. So we're going to get our new Manitoba notebooks ready. And we have x plus 6 over x plus 1 equals 4. And just make sure I copied that right. Yep. So I'm going to multiply everything by x plus 1. So we get x plus 1 here, just a 6, and then 4x plus 1 here. We're going to expand out x squared plus x plus 6 is equal to 4x plus 4. Bring all this over to the other side. X squared minus 3x plus 2 is equal to 0. This one is a fairly common quadratic, so you can likely factor it. If not, there's no shame in going to the quadratic formula. But we need two numbers that multiply to 2 and add to negative 3. That'll be negative 1 and negative 2. So x equals 1 and x equals 2. Solve the system, or solve the equation. Okay, if you wanted to, you could even plug them in. 1 plus 6 over 2 is 1 plus 3, that's 4. And 2 plus 6 over 3 is 2 plus 2, which is also 4. So these make sense. All right, so that was A part. I like that the questions get harder as we go along, so 1 should be fairly simple. B. Solve the equation x to the 5 plus 36x equals 13x cubed. Now this is something different. So we've got a quintic equation, something with an x to the 5 in it. But there's no quintic formula like there's a quadratic formula, so we're going to have to be a little sneaky. What we're going to do is we're going to bring this all over onto one side. So we had x to the 5 plus 36x, and that's equal to 13x cubed, right? Just double check. Yep. So we're going to bring the 13x cubed over to the other side. And then, well, we'd want to factor it, but it's kind of big. But I notice I got a factor of x everywhere. So I'm going to take that out. X to the 4 minus 13x squared plus 36. Okay, this is looking a little better. It's a quartic now, something with a power of 4. I think sometimes people also call it a biquadratic equation. Bi meaning 2, quadratic meaning the 2. But what are we to do? We don't quite know a formula for that. I mean, there is one, but it's really long. What we're going to do is we're going to say two things. First, so this is true. So either x is 0 or x to the 4 minus 13x squared plus 36 is equal to 0. So now this gives us a solution, x equals 0, but there's probably more. With something to the power of 5, you should expect about 5 answers. No more than 5, certainly. Just like over here with a quadratic. How many solutions can we have to a quadratic? We can have no real solutions, 1 real solution, or more likely, we usually get 2. So what I'm going to do now is, this is a nice little trick. I'm going to let y be x squared. So then this x to the 4 just becomes y squared. So y equals x squared, sub that in. Minus 13, it's not x squared anymore, it's y. Plus 36 is equal to 0. And this, it's likely we can factor it. Multiply to 36 and add to 13. Again, if you have trouble with it, quadratic formula all the way. But minus 4 and minus 9. But now I can take this y and plug it back in. So x squared minus 4 and x squared minus 9. So either x squared minus 4 is equal to 0, or x squared minus 9 is equal to 0. And those have some pretty quick solutions. X is plus or minus 2, x is plus or minus 3. So x can be minus 3, minus 2, 0, 2, or 3. Those are our solutions. And we've justified everything. We don't, you don't need to prove in the sense that everything needs a written sentence or paragraph explaining it. Our equations flow nicely. We've got our statements, either x is this or this, and then we solve this. It's quite clear what's going on. So that's question number 1 on the 2008 MMC. Join me in the next video as I take a look at question 2 and probably stop comparing this thing to the Euclid.